Humankind has now spent an entire decade exploring interstellar space. On August 25, 2012, NASA's Voyager 1 spacecraft was 18 billion kilometers from the Sun, and scientists determined that the vulnerable spacecraft had crossed the boundary between the Sun's influence and the interstellar medium. Now still going and still sending back data, Voyager 1 and its twin Voyager 2, which joined it in interstellar space in 2018, continue to conduct groundbreaking science. Launched in 1977, Voyager 1 and Voyager 2 were primarily designed to explore Jupiter and Saturn. Voyager 2 also visited Uranus and Neptune, while Voyager 1 instead prioritized Saturn's giant moon Titan, which sent it on a new trajectory to the edge of the solar system. It wasn't until after Voyager 2's flyby of Neptune in 1989 that Voyager's interstellar mission was created. Merav Offer, an astronomer at Boston University who runs a center called SHIELD that's revisiting Voyager's data in an effort to learn more about heliosphere, said nobody ever expected the Voyagers to leave the interstellar medium. They had a 5-year lifetime that was extended for another 5 years, then 10 years, but nobody really thought that they would be leaving our solar system. What the twin spacecraft have discovered about the heliosphere, the magnetic bubble that surrounds us, could have consequences for our understanding of life on Earth. Voyager 1 became the first human-made object to explore interstellar space when it was 122 astronomical units away from the Sun. Scientists know for sure that Voyager probes have crossed from the heliosphere into interstellar space because of particle density. The density was 10 times larger than what Offer and her team found in the solar wind at those distances. Voyager 2's instruments detected the same jump in particle density when it entered the interstellar space on November 5, 2018. The probes crossing into interstellar space may have been clear-cut, but the heliopause, a twilight zone between the bubble-like heliosphere and interstellar space, had unexpected properties. Each spacecraft took a couple of months to cross through, during which time they sent back data on peaks sent through in plasma density. Offer said, "We expected it to be a bleep, but the heliopause is not like a line or a door. It's much thicker and more complex than what we thought, but it's also a boundary that allows communication." The amazing discovery that particles come in and out of the heliosphere was from magnetic field data from Voyager 1 in 2012, then from Voyager 2 6 years later. Voyager 1 and 2's data on magnetic fields in the heliopause confused scientists. There ought to have been a change where the magnetic field from the Sun met that from the space, with theorists expecting a magnetic field from the galaxy to be inclined to the solar magnetic field. But neither Voyager 1 nor Voyager 2 detected magnetic field direction changes. When Voyager crossed, there was no change in angle. The magnetic field stayed almost solar-like with no rotation. It's still a puzzle, but Offer and her collaborators have a theory about magnetic field flux tubes in the heliopause that connect the solar field with the interstellar field. It's almost like there are these highways for particles to go in and out of the heliosphere. Adding that, it's probably a region where the magnetic field reconnects. The heliopause appears to be the wrapped surface of the heliosphere that responds to solar activity. But why remains an open question. What happens beyond the heliopause? What data has Voyager sent from interstellar space? To know more about these questions, stay tuned for my next video and subscribe to my channel. Thank you.